This is Brendan with Cusack Prep, and what I've got for you today is another video describing how to solve double angle identities problems. In the last video, we talked about double angle identities where we didn't just have cosine of 2x in an equation or just sine of 2x, but within those equations we had another trig identity. This video is to help you with a slightly different type of problem where you only have cosine of 2x or you only have sine of 2x. So for problem 1 here, we can see this is the case where we only have cosine of 2x. In order to solve this, I'm first going to add 1 to both sides and then divide by 2. Just some basic algebra to try to isolate the cosine of 2x function. So I add 1 to the right and I divide by 2, and I end up with cosine of x is equal to 1/2. Now, in order to solve this, you have to come up with 2x is equal to the inverse cosine of 1/2. And what this means is where on the unit circle is the x value 1/2, because that's what cosine refers to as the x coordinate. We know on the unit circle that this happens where cosine's 1/2 at pi over 3. And then also again in the fourth quadrant at 5 pi over 3. Now, normally this is where you would stop kind of in previous problems because you typically restrict your domain from 0 to 2 pi. However, in the case of cosine of 2x, you have to go all the way around the unit circle again. So I'll show you a little picture of what we're doing. So we know pi over 3 is right here, but there's another angle because of the 2x that can fit into the 0 to 2 pi range, and that's what happens when you go all the way around the unit circle again and you get to the same place. Once we divide both sides by 2, we end up back in that 0 to 2 pi range, even though this first value is not going to include that. So what I have to do to figure that out is I have to take pi over 3, and I have to add 2 pi to it. Well, at first you find the least common denominator, so you get pi over 3 plus 6 pi over 3, and you come up with this equaling 7 pi over 3. So that's going to be another one. If we do the same thing with 5 pi over 3 and we add 2 pi to that, we're again adding 6 pi over 3, so that's going to give us 11 pi over 3. Almost done, not quite there. Because we've currently just solved for 2x, but we actually need to figure out what x equals. So to do that, we're going to divide both sides by 2. Dividing both sides by 2 is the same as multiplying both sides by 1/2, so then our answers are going to become x equals pi over 6. It's pi over 3 times 1/2. 5 pi over 6, and then 7 pi over 6, and finally we're going to have 11 pi over 6. And notice all of these values do end up on the unit circle. They're in that 0 to 2 pi range, and that's because of dividing by 2, and that's why we had to go around twice to make sure we capture that. Second problem, I'm going to do a little bit quicker. It's the same idea. We're going to subtract root 3 over to the other side, so we're going to have sine of 2x. Divide both sides by 2 equals negative root 3 over 2. Same thing as before, we're going to do the inverse sine of negative root 3 over 2. You know your unit circle values well. You're going to know that sine is negative in the third quadrant and the fourth quadrant. Root 3 over 2 corresponds to pi over 3. Pi over 3, what's the word I'm looking for? Pi over 3 reference angle. So in the third quadrant, that's going to be 4 pi over 3. In the fourth quadrant, that's going to be 5 pi over 3. But once again, we have to do another full loop around the unit circle. So to 4 pi over 3, I need to go ahead and add 2 pi. So I'm adding 6 pi over 3, and that's going to give me 10 pi over 3. To 5 pi over 3, once again, I'm going to go ahead and add 2 pi, and that's going to give me 11 pi over 3. Once again, I have to divide both sides by 2 or multiply by 1/2, and when I do, I end up with 4 pi over 6, 5 pi over 6, 10 pi over 6, and 11 pi over 6. Two of these values reduce. We can simplify the 4 pi over 6 fraction to be 2 pi over 3, 5 pi over 6. Let's see, those are both divisible by 2, so we get 5 pi over 3. And 11 pi over 6 can't reduce. And that's it. That's how you deal with trig identities double angle identities that just have one identity within the problem. Hope you found this video helpful.